Our story begins about 4.6 billion years ago. Imagine a vast cloud of gas and dust, a nebula drifting through the cosmos. This nebula, a chaotic nursery of cosmic matter, held within it the seeds of our solar system. A disturbance, perhaps from a nearby supernova explosion, sent shockwaves through the nebula. This caused the cloud to collapse in on itself. As the cloud contracted, it began to spin faster and faster, like a spinning figure skater pulling in their arms. The center of the cloud grew denser and hotter, eventually reaching temperatures high enough to ignite nuclear fusion. This is how our sun, a giant ball of burning hydrogen, was born. The sun's birth wasn't a solitary event. The remaining gas and dust in the nebula continued to swirl around the newborn star, forming a swirling disk called a protoplanetary disk. Within this disk, tiny particles of dust and ice collided and stuck together, a process known as accretion. Over millions of years, these particles grew larger, forming pebbles, then boulders, and eventually planet-sized objects. These objects, the seeds of our planets, continued to attract more material, clearing their orbits and shaping the solar system we know today. Let's fast forward a few million years. Our young planet, still in its infancy, was a hot, violent, and chaotic place. We call this period the Hadean Eon, named after Hades, the Greek god of the underworld. It's a fitting name, for Earth at this time was a true inferno. Constant bombardment from asteroids and comets, remnants of the solar system's formation, released tremendous amounts of heat. This intense heat, along with the heat generated by radioactive decay within Earth's interior, kept the planet in a molten state. Imagine a world covered in a magma ocean, constantly churned by volcanic eruptions and asteroid impacts. The atmosphere was a toxic mix of gases, devoid of the oxygen we breathe today. It was a harsh and unforgiving environment, a far cry from the life-sustaining planet we know. But amidst this chaos, the seeds of order were being sown. Deep within the molten Earth, a process called differentiation was underway. The denser materials, primarily iron and nickel, sank towards the center, forming the planet's core. As Earth continued to cool, the outer layer of molten rock began to solidify, forming the planet's first crust. This crust, however, was nothing like the continents we know today. It was a thin and fragile layer, constantly broken and reshaped by volcanic eruptions and asteroid impacts. The lighter materials, such as silicon, aluminum, and oxygen, rose to the surface, forming the mantle, the thick layer of rock that lies between the crust and the core. This process of differentiation, the separation of Earth's interior into layers, was a crucial step in the planet's evolution. With the formation of the crust, Earth's surface began to take on a more familiar form. Volcanoes erupted, spewing lava and gases into the atmosphere. These eruptions released water vapor and other gases from Earth's interior, contributing to the formation of the early atmosphere. The cooling process was not uniform, and areas of the crust cooled and solidified faster than others. This uneven cooling created convection currents in the mantle, setting in motion the forces that would shape Earth's surface for billions of years to come. As Earth continued to cool, the water vapor released from volcanic eruptions began to condense in the atmosphere. Over millions of years, this water vapor accumulated, forming thick clouds that blanketed the planet. Then, the rains came. Torrential downpours lashed the Earth's surface, filling the low-lying areas with water. These basins, formed by the constant bombardment of asteroids and the movement of Earth's crust, became the first oceans. The early oceans were not the serene blue expanses we know today. They were hot, acidic, and rich in dissolved minerals. However, these primordial seas would become the cradle of life, the setting for one of the most remarkable events in Earth's history, the emergence of life. The constant churning of the mantle, driven by the planet's internal heat, created volcanoes that rose from the ocean floor. These volcanoes released gases and minerals into the water, creating a complex chemical soup that would prove to be the perfect breeding ground for life.